Okay, final thing for the night, we're going to talk about confidence intervals for proportions. We're going to learn about creating a confidence interval from a proportion. It's not too hard. So what a confidence interval is a range of data that approximate an unknown. That really is a misnomer. I shouldn't say statistics. It's approximating an unknown parameter. Because it's based off of a proportion. The easiest way to do this is just to generally look at an example. And this will kind of date me a little bit, but suppose that an initial group of random 800 people are invited to see the new Avengers 4 movie before it is released. At the end of the movie, each person is given a survey where the participant must decide whether they approve of the movie in its current state or if Disney should change something in the movie. Of the 800 people, 94% say that the movie is fine the way it is. Determine a 95% confidence interval stating that the true proportion of people who like the current movie would be for a total population. So here's how it works. We right now know that based off the 800 people, that 94% people like it. So don't worry about this 95% confidence interval. We'll talk about that in a second. But just note that our P is 0.94 and our N is 800 right now. So our example, our mean is in this proportion is 94%. And remember what we talked about last time, that our mean should be approaching, as long as it's large enough, it should be approaching the population parameter anyway. So 800 would be large enough. So we can reasonably believe that if it's not 0.94, it's going to be around 0.94. We still want to use the standard deviation, which we call a standard error again. And that's our formula for this. So basically we want to do the square root of 0.94 times 1 minus 0.94 divided by 800. And that'll give us 0.0084. This is something we need to know for a confidence interval, because that's basically something we need to see how far it's going to go out. Now, all you need to know is how to find how wide the confidence interval is. So we found the average, we kept it like that. We found the standard deviation. We're going to keep it like that. So now we need to find out how wide we want our confidence interval to be. So, a 95% confidence interval. A percentage tells us the length that we want. The percentage tells us the length that we want in the interval. So the 95% confidence interval tells us we want a wider confidence interval. So the way it works is this. So I'm going to do 1. To find the length, I have to find the length. We find the length by taking 1 minus the confidence interval. So I have a 95% confidence interval right now. I'm going to do 1 minus 0.95. And that's going to give me 0.05. And I'm going to divide it by 2. Divide it by 2. And that's going to be 0.025. And then what I want to do is I want to look at my z-chart to find a good match for this. So let me pull up a z-chart real fast. That'll be fun. Okay, so what I'm going to do is I'm going to look inside here, and I'm going to look for the closest thing to 0.025. So, or if I can get 0.025, that would be great. Like here, this is 0.02500. So that's what that is. Okay, so if I look to the left, that's 1.9. If I look to the top, that's 6. So that means it's going to be negative 1.96. So if I go back to my chart here, I pull a negative 1.96. Now this is a length factor, so we don't want negative. So when we get negative, we automatically want to, and we're going to get negative every time with this method, but we automatically want to change it into a positive. So that's why I get a 1.96 here. Okay. So that's what we're going to get. Now, to complete my confidence interval, what I'm going to do is I'm going to take that 0.94, And then I'm going to add and subtract 1.96, which I just got, and then the standard deviation that I got from the other page, which is 0.0084. Then I'm going to multiply those together. So 1.96 times 0.0084, 0.94 plus or minus 0.0165. I'll keep it at 4 decimal places. And then I want to add and subtract this. So 0.94 minus 0.0165. Okay, so that gives me 0.9235. So this was 0.94 minus 0.0165. Okay, and then I want to do 0.94 plus 0.0165. So that gives me 0.9565 or 0.94 plus 0.0165. Okay, and so this is my confidence interval. What this basically states, and I'm actually going to write this sentence out every single time, is that I am 95% confident that the true proportion of, let's take a look, what are we talking about here? Of people wanting to go see Avengers, right? Yep. Of people who want to go see Avengers, as is between 92.35% and 95.65%. And that's what that means. So basically, the true proportion, the actual proportion of people who like the movie as it is somewhere between those two proportions. You're not going to get, I mean, you could make it more precise by shrinking the confidence interval, but you would shrink it down to say like a 50% confidence interval. That means you're not as confident in your thing. So it's far more accurate this way. It's more than likely in there, but you're just not quite sure where it is. It could be 94, it could be 95, 95.5. But you know it's in there somewhere. Or at least it should be. At 95% confidence, it should be in there somewhere. Okay. Second example. On a certain campus of students, a poll is taken of 650 random students. It's determined that 12% of the students are left-handed. Use this information to determine an 80% confidence interval for the true proportion of left-handed people. So we're going to do the same thing. So we got our P. Our P is 12%. Really, it's P hat. But I've never been a stickler for those things. Then for standard deviation, 1 minus 0.112 times 0.112 over 650. And so I want to do that real fast. So that gives me 0.0127. Okay, so I have that now, and now I want to get my length factor. So I'm going to do 1 minus 0.8, because that's my confidence interval. I have an 80% confidence interval. And I want to divide that by 2, so that gives me 0.20 divided by 2, 0.1. Okay, so I'm going to go look at my chart. So let's see, look inside for the thing closest to 0.1, which looks like it's going to be between these two here. So let's see. I want to take the average of those two, so that's 1.28 and 1.29. So if I take the average of those two, that would be 1.285. So I'm going to end up with, because I'm going to knock the negative off, 1.285. Okay, so then I'm going to bring it all together and say 0.12 plus or minus 0.0127 times 1.285. Okay. 0.0127 times 1.285 is 0.0163. So 0.12 minus 0.0163 is 0.1037. And then if I add, I get 0.1363. Okay, and then that's my confidence interval. And I can say I am 80% confident that the true proportion is between, well, the true proportion, before I do that, of left-handed people I should probably say left-handed students, but that's fine, is between 10.37% and 13.63%. And that's it. You have to write that sentence every single time. You must. You must. Okay, so we got that down. Now, third example. A recent study of 450 students taking statistics at the college level yielded a 65% pass rate. Estimate the true pass rate for all students at the college level with a 97% confidence. Okay? So, once again, we have a P that's equal to 0.65. We have an N that's equal to 450. And we're just going to go ahead and find our standard deviation, which is 1 minus 0.65 times 0.65 over 450. So let's see. .0225. Okay, and then I need to find my length factor. So that's going to be 1 minus 0.97 divided by 2, which gives me 0.015. And so I want to look that up in my Z's chart. I think fortunately this one comes out to be one really nice one. So let's see, 0.015, 0.01. Yep, right there. 0.015 is 2.17. Okay. So let's bring this up. Okay. So now I got that, and I'm going to do 0.65 plus or minus 0.0225 times 2.17. So 0.65 plus or minus 0.0488. Okay, so let's see. 0.65 minus 0.0488 gives me 0.6012, and then 0.65, oh, nope, that's right. plus 0.0488 gives me 0.6988. And once again, I'm going to write myself a little sentence here. So I am 97% confident that the true proportion of pass rate, it's kind of an awkward sentence, but okay, maybe okay, in stat is between 60.12% and 69.88%. Okay, so the next thing we kind of want to talk about is margin of error. Margin of error is a number that corresponds to the z-critical value multiplied by the standard error. And the z-critical value is just that. I didn't really mention it too much, but the z-critical value is that length factor that I calculated. So like in the last one, that was 2.17. So really, the margin of error is that thing you're adding and subtracting to the proportion. So if you go back here real fast, this final number here is a margin of error. So in this case, it has a margin of error of 4.88%. So what we can do is we can kind of look at some things and work them backwards to try to figure out what we need for certain situations to be within a certain margin of error. So, for instance, here is our formula for calculating the sample size that we need to be within a margin of error, where E is the margin of error. So what's the appropriate sample size for 95% confidence interval based off of examples 2 with a margin of error of 4%. So in example 2, was the people with left-handed, 12% were left-handed. Now I'm not going to take out the n because that's what I'm searching for. I'm searching for what the appropriate one would be in this situation. So to figure this out, I'm just going to do n equals 1 minus 0.12 times 0.12 times z-critical squared. Now 95%, I'm not going to go back and figure this one out. I have it memorized, and you probably should too. A couple of these ones I use frequently, you should memorize it. It's 1.96 squared divided by the margin of error squared, which is 4%, which is 0.04 whole squared. Okay, so if I do the quick math real fast, that gives me about 253.54, which I'll round up since we want whole people here to 254. Okay. Then let's try one more real fast, and that'll be the end. Using the information from the confidence interval, example number 3, determine what the appropriate sample size would be for a 90% confidence interval with a margin of error of 5%. So my third example had 65% pass rate, so we'll do that. So we have a 65% P. So 1 minus P times Z critical squared over E squared. 1 minus 0.65 times 0.65 times 1. Okay, so this one for 90% is always 1.645. So you might want to try to memorize that. And then we're going to divide this by the margin of error squared. So when I get that, that gives me about 246.24, or roughly 247, since we're going to round up. Okay, now the last thing I want to show you before I head out is how to find a confidence interval in StatCrunch, because again, my students do love that. So I'm going to do it with this example here. So we've already kind of figured out our own thing. It's going to be similar, but a little bit different because, StatCrunch will be a little bit more precise than we are. So in order to do this, we need to note the P is 0.65 and the N is 450. So if I go to StatCrunch real fast, what I can do is I can go to Proportion Stats and hit one sample with summary. Now, here's the thing that's a little bit different. You can't put in 0.65. You have to actually do 0.65 times 450. And so you can then put in 292.5. But that's a thing to remember. You cannot just put the percentage in. You have to multiply the percentage times. Basically, just finding the average that we did before, but it's not the average in this case. So just n times p. And then so it'd be 292.5 over 450. And I want to hit this thing that says confidence interval down here. And in this case, I wanted a 97 confidence interval. This method doesn't matter. And I'm going to change that to 0.97 because I want a 97% confidence interval. And I'll hit compute. And so it's going to give us our confidence interval just like that. So if you see, this says 0.6012, which is pretty bang on what we had, and then 0.6988, which is pretty close. If you round it up, you get 0.69988. So, still pretty close. All right, and that's it.